Hello everyone, this is Venu. Today I am going to give a small demo on carbon and its compounds from class 10. So, what is the definition of carbon compounds? Chemical substances which are made up of carbon are known as carbon compounds. Examples are food, what we are eating, clothes, what we are wearing, medicines, what we are taking daily are known as carbon compounds. The books, plastic, etc. all are made up of carbon, and as well as our human body also made up of carbon. What is the main source of carbon? Earth crust containing 0.02% of carbon compounds in the form of carbonates, hydrocarbons, coal as well as petroleum. As well as atmosphere also containing carbon compounds in the percentage of 0.03 in the form of carbon dioxide. So by this we can understand that carbon is having a very much importance in our life. So we need to know about the carbon atom first. So carbon atom atomic number is 6, its atomic weight is 12. So it has 6 electrons, 6 protons and 6 neutrons. The protons and neutrons are present in the nucleus and 6 electrons revolve around the nucleus. These 6 electrons are distributed in the two shells like 1s2, 2s2 and 2p2. So by this we can understand that the outermost shell of carbon atom is having of 4 electrons only. So it requires 4 more electrons to complete its octet, that is the stable electronic configuration. So for that it can go for sharing of electrons. Generally, every element in the periodic table try to get the noble gas configuration, nearest noble gas configuration by the sharing of electrons or by losing or by gaining of electrons. So ionic compounds can lose or gain the electrons to get the outermost octet configuration, but carbon can share their electrons out valency electrons with that of similar carbon atoms or other type of atoms. Why? Because if carbon loses 4 electrons, so it gets C4 plus. It is very difficult because it requires much more energy to remove 4 electrons. If carbon gain 4 electrons, it gets C4 minus. It is also difficult for the nucleus to handle 10 electrons with the help of only 6 protons. That's why it go for sharing of electrons. So here the example methane. So in this structure the valency electrons of carbon can be shared by 4 hydrogen atoms. So it can form methane. Similarly, hydrogen, oxygen, nitrogen atoms can also share their valence electrons with similar or different atoms. Examples are hydrogen gas, oxygen, nitrogen molecule, water molecule and ammonia. Allotropes of carbon. So what is mean by allotrope? Allotropes are nothing but different structural forms of a single type of chemical element. Examples are diamond, graphite and fullerene. All are having only single chemical element, that is carbon, but they are different in their physical as well as chemical properties from one another because they are allotropes of carbon. Here if you take the diamond and graphite, the graphite is having of sheets of hexagonal lattice, but the diamond is having of tetrahedral lattice. The diamond does not conduct electricity through it because the valency electrons are shared with the 4 carbon atoms and form tetrahedral lattice. But in the case of graphite, it has free electrons and that free electrons are helpful for conducting of electricity structures. So then coming to the discussion about the versatile nature of carbon. So far 3 millions of organic compounds have been identified by the scientists. So this is due to the characteristic properties of carbon. What are they? That is the catenation capacity and tetravalency of carbon. What is meant by catenation capacity? Carbon has the unique character, that is the formation of bonds with a similar type of atoms, and that helpful for formation of large number of cyclic as well as chain like structures. And coming to the tetravalency, carbon can form 4 bonds with the other atoms. So this helpful for the the formation of a large number of organic compounds. Then coming to the discussion about the saturated and unsaturated compounds. What are saturated compounds? Compounds which are having of sigma bond in their entire structure are known as saturated. If the hydrocarbons which are having multiple bond in their structure are known as unsaturated compounds. So examples for saturated are alkanes, that is methane, ethane, propane, butane, all are having of sigma bond in their structure. But in the case of unsaturated, so if compounds having double bond in their structure are known as alkenes. If hydrocarbons which are having triple bond in their structure are known as alkynes. In double bond, one is sigma and one is pi. In triple bond, one is sigma and two more are pi bonds. In this table, we can see the various compounds of various hydrocarbons with their structures: methane, ethane, propane, butane, pentane and hexane. Coming to the structural isomers, compounds which are having same molecular formula differ in their structural representation are known as structural isomers. Examples are N-butane and isobutane. In N-butane, all the carbon atoms are linked with each other linearly, but in the case of isobutane, the compounds isobutane is having a branch. Some compounds have carbon atoms arranged in the form of ring. Examples are cyclohexane as well as benzene. Cyclohexane doesn't have aromatic character, but benzene is having of aromatic character. What is meant by aromatic character? Here, the compounds which are having cyclic planar and conjugation, as well as which satisfies Huckel's rule, that is 4n plus 2 pi electron. So, the compounds are considered as aromatic character. So, this is about for my demo.